we will continue the lesson. So I was in drawing the outer shape of the model. So I'm actually, when you get a SolidWorks model, you try to do complete the easy things first. Better you complete the outer things and go to the inside. That's going to be easy. So when I try to make this fully defined, this additional dimension was put by the software. So I didn't put this. This was the additional dimension he put by the software itself to make it fully defined. So you can see this additional dimension has been done. So it's not going to be very harmful for my drawing. So I will keep it as it is. So if I delete this one, this drawing should be underdefined. So it's now underdefined. So you can see blue lines appear. So that's the dimension the software has done for me. So now it's again black. So we will now concentrate on the inside of the drawing, inner parts. So we need to have slots here. So slots are placed along a circle here. The diameter of the circle is 70. So if you want, you can draw this circle, or else without the circle also I can place it. So the slot angle is 45, from the horizontal is 30. So this is the slot we need to draw, not the others, because others don't have any dimensions. And the slot thickness is 10 millimeters. So I can draw a rough sketch using the center arc slot. We can draw this. So I will use the center point arc slot. This is the center, and we'll just roughly start from here and start here. And it says add dimensions. We'll add dimensions automatically. Then it's easy for us. These are rough measurements. So now it should be 45 degrees. Thickness is 10, and the diameter is 70. So this radius should be 35. Thickness is 10, and the angle is 45. But I have to give another angle, that is from the horizontal is 30 degrees. So can we give that angle? Because I don't have any center lines, it's going to be somewhat difficult for me to give that. So if I just try to click on these lines, these points, I cannot give the angle. So better we draw additional center line for this. You may have already drawn the center line, so I didn't draw. So we can use the center line and this point and give 30 degrees. So it's again difficult from the point. It's not going to be easy. So we will draw additional center lines. Center lines you can draw as much as you like for you can get the drawings accurately. So these center lines will not give any problems for 3D extrusions. So we can select this one and this one. Sorry, these two lines and give the lines. And now the slot is nicely placed, fully defined again. So I hope you understood how the slot has been placed. We use this center point arc slot, give the center, start and ended, 45 degrees, 35, 30 and 10. So the slot is nicely placed now. And now I need 3 slots. So what we can do is we can apply a circular pattern. Entities to patterns is this. So here we are selecting all these entities. Automatically the slot has been taken and the center point is now wrong. If you want, you can delete this, or else you can try to drag this arrow here from here to here. Sometimes it may work. It depends on your mouse and the other computer speed. So if it is not working, manually dragging. If it is not working, you will delete this and give this point again. So I will do it again. entities to pattern is this slot entity, automatically taken. Center point is wrong. Delete this and give me this as this one at the center. Still not taken correctly. So if it is not taken correctly, I have a problem. Entities to pattern. Center point is this slot shape. This is not taken correctly. Drag and drop like this. If this deleting thing is not working, you can just drag and drop the arrow from the head and put it there. And the parameters are here. I need 3 and press O. Drag and drop like this. Parameters 3 and OK. Should go. Now I can make it 3D. Automatically the inside loops will be on. So this is the. So check whether you are okay with this drawing and let me know if you have any questions. Any questions up to this point? We have done 5 chapters. I did covered around 80% of the content. Some of the things I skipped, so we may come back again and talk about them later when we need them. Any questions up to this point? What we discussed before we start the new chapter? So this course is, as I told you, it's somewhat a crash course. So you have to do some work by yourself at home, and otherwise it's going to be difficult. This chapter talks about creating additional planes. Now, when we want to draw complex designs, for an example, if I just look at the tutorial number 2 here, or number 3, these kind of designs. So we are moving from the basics now. So we need to have additional planes drawn here, and we need to know the cutting operations. So some of the advanced concepts we have to know now. So we will look at how to create additional planes and how to do these cutting operations in our drawings. Now here all automatically the cutting happens because this is coming from a loop. But if you want, there are cutting tools available under extrude cut, and revolve cut is available. So we can remove the material as requires. So we will look at these things later when we discuss the tutorials. So first we will look at how to create additional planes. Why we need additional planes? When you go to a complex design, when you want to do complex drawings, you need to know how to add additional planes and additional axes, additional say points and other things in SolidWorks. So we will first look at the plane theory, how to create your own planes, reference planes. And we can create our own axes, and we can create our own points, we can create our own coordinate systems. So we will look at how to do those things. We will first start how to create additional planes. So when we started drawing, now I think I shared some files with you, some part files with you guys. So you need to use these files for this chapter. So these files have been shared by me. So you need to open these files and keep it aside in your computer. So we will start by using these already model files and apply the tools and see how it works. So these are called part files. I have created a lot of part files. So I shared this chapter 6 with you. So you have to have this in your computer to start this lesson. So we are going to start creating additional planes. So I will open this part file. So download it from your Gmail or whatever the thing they shared with you. So have this file with you. Otherwise we can't continue the lesson. Okay. So now first thing in this slide they have created a plane. We have several ways of creating additional planes. The easiest one is to create a plane offset to another plane or a surface. Creating a plane at an offset from an existing plane or a plane. So why you may think why we should do these things. So sometimes we may have to draw a sketch and not on the surface here. We may have to draw a sketch somewhere else. So if you want to draw a sketch on top of this surface, which is easy. So I will try to draw a cylinder on top of this face. How can I draw that? So if I want to model something else on top of these faces, we can do. But I can't model anything here. Can't do because this is a curve. This is not a plane. So if I want to draw a sketch here, we can just click on this and go to sketch tools here. And now the sketch mode is started. So I can come here and draw the shape I want. So make sure you put the dimensions and make it fully defined. So we need to have fully defined sketch always. So I will just give reference from here. Another reference from this edge. Likewise. Now it's a fully defined sketch. Fully defined. Now we can come here and go to extrude tools and make a extrusion like this. So I use an existing plane to do this design. I use this flat face. I can use this one, but I can't use this. I can't use this because these are curves. So if you want to do a design, just click on the plane here, face here, and go to sketches direct. And you can draw the shape you like and make it fully defined. Now this is underdefined. And put as use the extrusion tools and do the design. So you can build up the models like this. So you can build up like this easy. But suppose you want to draw a sketch in another plane. So you need to have an offset and start my sketch. There are instances that way you can't use the original planes. You have to create additional planes and do the design. Sometimes you need to create additional planes like this and do the designs here. Sometimes we need to create planes like this and do the designs. So sometimes we have to create planes on a curved surface because we can't draw anything here. So how can I do this? So that's the lecture I'm now doing. So we will start from the easiest one, creating an offset plane. So I hope you are following me. I will delete these things. So we have to go to these reference geometry methods and select the first one. Yeah, I'm going to create planes. So when you click on that, I'm getting this dialog box. It says we need to give 3 references to create a plane. So in the worst case, we have to give 3 references. But for the offset plane, we need to give only 1 reference. That is, we need to give the gap between this face and the offsetted plane. So only 1 reference is enough. But when it comes to a case like this, we need to give 3 references. First one, second one, third. So if you select points to create a plane, if this is the worst case, you need to give 3 references. If you just select a parallel face, you need to give only the gap between the 2 planes. So worst case is 3 points. The best one is easiest one is the only the 1 reference. So when you click on this face, automatically it will create a plane which is 10 millimeters away. If I want to change the distance, you can change it like this. If I want to flip it, you can flip to the other side. So this way, and I will put it back this side, and say 10 millimeters. And if you want, you can have multiples like this, also multiple planes. So we have one only, and it says I selected the face one, and the gap between the planes are 10 millimeters, and it says fully defined. So if you are getting this word called fully defined, you don't need to give the other references. We don't need to give the others. We need to give more than required. So you just give the give this face as the first reference and press OK. Now I created the additional plane. So when you come here in the design tree, we can see an additional plane has been created. If you want to hide the additional plane, just come here and click on the hide tool. Additional plane is hidden. These normally original planes are always hidden. So if you want, you can make it visible. These are by default, these are hidden. So you can hide it like this. So now I created the additional plane. So if you want to do a design, just click on this, go to sketches, select the sketch tools you have, and create something like this. So we can easily create an object like this, and if you want, you can hide this plane. And this is my design. Normally we don't have designs like this in mechanical. You have to have a support, but it's possible in SolidWorks. So I hope you understood what I did. Now if I try to delete this plane, what happens? This plane is the parent of this boss extrude. So these 2 sketches will be deleted. They cannot sustain. So if you delete this plane one, this is the parent, these are the children. So these are the dependents. So if you just delete the parent, what happens? The children also will be deleted. So always remember, SolidWorks has this parent-child relation. So if you do something for the parent, the children will not sustain. They will also be collapsed or deleted, or it will give errors in your designs. So I will do it again. Select the plane tool. Select the face you want to get an offset, fully defined. Give the value. Press OK. Now I created the plane, which is the easiest one. So I hope you understood the easiest one, how to create an offset plane. Any questions, always let me know. I will stop it and again explain. Then we can create a plane at the middle of another line. So first selection will be this one, and the second selection is the midpoint of this line. So now I am giving 2 references. So I will do it now. Suppose I want to have this plane going in the middle here. So we can edit this one and give a second reference. Second reference is the midpoint here. So automatically the midpoint will be captured. Click on the midpoint. Now there are constraints here, that's why you are getting an error. We will do it from the beginning. I will delete this and start again. First is this offsetted one. Second reference is this midpoint. You can see quickly it's getting the relations automatically working, coincident. Press OK. Now the middle point is captured as the second reference. You can see first one is this face, second one is the midpoint. You can easily create a plane, fully defined plane, which is going through the middle of this line. So when you do the tutorials, when you practice the software, you will automatically select these methods and do it. For the time being, you will not understand why we need these things. When we do some tutorial questions, you will use these things, then you will understand the importance of these tools. Now we will look at another method of creating planes. If I want to create a plane at an angle like this, how can I do it? So you may have to do designs here. So that's why we need an angle. So how can I do? So you just come here, select this as the first reference, select this edge as the first reference. Now still it's underdefined. Now we can have lot of planes around this edge. Then second reference will be this face. So when you select that one, automatically the perpendicular relation is going to work. So if you want, you can apply the angle here. Say I turn this on and give say 45 degrees. So automatically the perpendicular relation coming taken by the software. But I can enable this button here at the angle and give an angle. And if you want, you can flip the angle this side. And if you want, you can have a lot of angular planes like this. So you can just play with these things and see. So the first reference is this edge. Second reference is this face at an angle 45 degrees. So I created a plane like this. So I hope you understood how to create a plane at an angle. So why we need these things? Basically, we can draw sketches on this. Go to sketch tool. I can draw a circle. So I will select this plane, go to sketches and draw a circular shape here. So you can see how the circular shape is drawn on that plane. And if I extrude it now, what happens? Extrusion happens. Suppose I want to have an extrusion up to this point. How can I do it? So you can flip it like this and extrusion happening here. Now blind value, I don't know this blind value exact. So I cannot give a blind value exact. So there are easy tools available here. We are going to discuss some tools here now. One is, if I want to go up to this face, there's a tool called up to surface. So you can select this surface as the second reference. So up to surface, and I'll select this surface as the ending face. Or else there's a tool called up to next. Up to next is software automatically finds the next surface. So if I'm going fast, I hope everyone is created this plane, and you can do a sketch on this, and we can go to editing mode again. Now go to features, extrudes. Now the extrusion happens this side, so I have to flip it. Now I can't give blind value because I don't know this value, and we can use the software help up to next. Automatically it will find the next surface. Or else you can use this up to vertex. Vertex tool, if I select this vertex, this is the result, but you can see it's coming and going inside. But here, since we merged the results, there is no problem. So material coming inside. But since we are merging the results, there won't be any problem with the material intersection. Automatically it merges. Or else you use up to surface and select this surface. Nicely stopping. If you select this surface, it's coming up to here. You can see it's coming some out of this boundary also. We are merging the results. So there are a lot of ways of doing this. Blind value is not going to work. If you give through all, what is happening? It's going through everyone, which is the worst case. Up to vertex is, we can select the vertex like this here. So it's going up to this vertex. So the best option here is up to surface, or we can use up to next. Next is, this is the next immediate surface. So I am merging the results, so there will be no problems in material intersection. So if I use this up to surface, so if I use up to vertex and select this vertex, what happens? It's coming and going through this. If I select this vertex, it's not coming up to this vertex. You can see that is okay. I will get the same outcome again because I have merged my results. Okay, so when I check my weight calculations now, I will come and check my weight. It says 181.17. So when I merge the results, it's not going up to this, it's not going inside 181.7. So remember this value. I will take a snapshot. These values. Now, if I unmerge it, what happens? If I say unmerge, this extrusion goes up to here. Say if I come and check these hidden lines on, so you can see the extrusion going up to here. So you can always come here and change with the visual appearance. I will turn the hidden lines or wireframes on. You can see the extrusion coming up to here. Now when I check the mass properties, it's 183.1. So the mass is increased a little bit. Volume has been volume, you cannot get a correct answer. Mass has been increased a little bit because this area is coming into play. So you can see the difference between merging and unmerging. So when you do a design, please be careful. Software automatically merge the results. Otherwise, if you unmerge it, it will go inside the other parts. So hope you understood what I'm saying. And you can see in the design here, I started with a circular shape, and now this is ends up as a ellipse shape. So this is in ellipse shape. I started with a circular shape. So I hope you understood why this is happening, because of this angle problem. So I started with the circular shape. I will delete again and do it. So I hope everyone is okay with creating the plane. So I will do it from the beginning again. Go to features, reference geometry is plane. Select this edge, and second reference is this face, and I need to give an angle. Click on this, and I gave an angle 45. Now I click on this one and go to sketches here, and just click on the face like this and created the sketch, and go to extrusions. Blind will not going to work. We will use up to. We have to select change the direction, and we will select up to next. So I am starting my sketches from the sketch plane I used. There are other ways of starting this. We will discuss these things later. And I ended up with up to next. So I started with a circular shape and ends up with an ellipse shape. So I hope you understood why we are getting an ellipse shape, because of the angle. So if I just look at this normal, still this has a problem with this. I'm repeating up to next. Click on this and we can go to normal to sketches and click on this again. If you want, you can change this like this. So you can see how I have drawn it. Started from a circle and ends up with the ellipse. So when you increase the diameter, you can clearly see that. Circular shape ends up with ellipse. So when you click on this and take a normal one, again normal, you can see how it works. And if you just if you start from here, what happens? Suppose somebody wants to start the drawing from here and go up to here. Can be done. So we have to give an angle for my extrusions. So are you okay up to here?
Yes, sir.
So I'm going to start from here and give an angle to the extrusion. So how can we do that? So there are ways of doing it. In chapter 5, we have that concept. So if you want to start from here and have an angle for the extrusion, what can we do? So I will just start from a circular shape, which is easy. So I will start those circular shape. Now what happens when I extrude? It's always going 90 degrees. But if I want to have an angle for the extrusion, there's a tool available in extrusion which is not working at the moment. So I have to add an angle for the extrusion. There's a tool here, direction. So now I have to show the software that I should travel at an angle. So there is no way of showing it at the moment because I need to give an edge or a line or a direction. So if I just delete this, first what should I do is I should create an additional direction or an additional line showing this angle. So what I'm going to do is I'm going to click on this, go to sketches. So if you want, you can make it perpendicular to the screen like this and draw an additional line to show the direction of this extrusion. So if I want to get a perfect parallel lines here, what we can do is we can click on this one and get the references. You can see how it works. So these are some tricky areas in SolidWorks. I will do it again. My idea is to get a direction parallel to this and have an extrusion from this side to here. So what I'm going to do is I click on this one, go to sketches, go to line tool, or a center line tool also will work, center line tool or line tool, no problem. Click on here and I want to have a parallel line uh, to this one. So you just click on this and hover over here, you can get the parallel reference. So this is how we create parallel lines. So I created the parallel line for this edge of the cylinder. Now what we can do is we click on this and go to sketches and create my circular shape. Now these are two different sketches. So sketch 17 is for the direction, sketch 18 is for the circle. So now extrusion happens this way. I want to follow this direction. You click on this blue box here and give the direction as this. So now you can see how the direction applied onto the extrusion.
So can you repeat that?
Yeah, are you okay with this line? Why I created this line is to show the direction for the extrusion. Now you can see without creating these planes we can do, but we have to do a lot of work. So if you create this plane, it's a very easy operation going from this side to this side. But when I want to go from the parent model to the other side, I have to do a lot of other work. So I'm doing a lot of other work, creating these additional directions, lot of things I have to do. This is easy. Creating a plane and going this side is easy. But I am getting the ellipse shape. Now if I want, I can draw the ellipse shape and do it, or I'm just drawing a circular shape for the time being because it's easy. So I hope you understood how to create these sketches. So I am going back, click on this, make it perpendicular, then it's easy. Click on this and make it sketch. Now I am in the sketch mode. Now you can click on the line, start from here, and I want to have a parallel line. Just click on these things. Just go through this one and you can see the references come in this one or this. Software will automatically do it for you. Press the escape key and exit. So this is created to get the direction. This is an additional work. Now click on this and go to sketches and create the circular or ellipse shape you want. Make sure you have two sketches and go to extrusions. And now I have to give the direction. Direction is taken from this sketch or this line. I hope you understand. So I have to have two sketches. I need to have additional sketch. Then if I just increase the blind value, this is my result. But if you want to get a flat surface here, better you select up to surface and select this plane. You can see how it works. So I selected up to surface and selected this plane I create. Then that will make sure you get in a cut, nice smooth cut. If I just use the blind value, my output is something like this kind of a vertical cut. So if you want to have an angle cut, blind is not going to work. You have to use up to surface and select this. Got it. So if you look at the output here, this shape will be ellipse. This shape is circular. So really understand. So this is circular, this is ellipse. This is circular, this is ellipse. You can see. Okay. So I hope you understood the concepts. So this is circular. I can put the wireframes on. Circular ellipse, circle. So there's a clear difference. So when you start from here and going here, I started with the circle and ends up with the ellipse. I started with the circle and ends up in the ellipse in this other direction. So it's very important to select the directions or the working planes when you start a drawing. So you can do this thing and check whether you understood this. Anyway, these videos are recording, so you can again watch it later also. So we will continue. So I hope you understood what I did. This is actually the most important chapter in SolidWorks. Without knowing these concepts, it's very difficult to create complex designs. So we will look at the next one, creating a plane passing through lines points. So we have to create a plane. Suppose we need to create a plane like this. So how can we do it in SolidWorks? So I will delete these things. So if I delete all these things will be children, all are going to have problems. So you can see a lot of things have been removed automatically. Now I want to create a plane connecting this one and this one. So we can go to references. If you just select this edge, it's floating still. I need to select one more point. So now it's fully defined. So I selected the edge. Edge has lot of points and one point from this place. So we can have a plane like this. Suppose if you select 3 points. The worst case is selecting this point and this point still floating and this. So you need to have at least, worst case is you need to have 3 points to create a fully defined vertex 1, vertex 2 and vertex 3. So this is the worst case. I hope you understood. So if you select an edge, edge has a lot of points. So you don't need to select 2 points. You can select an edge and a point and create a point. So this is the worst case. Select the first point, second point. This is better than this one. This has lot of points, so you need to select edge and a point out. So hope you understood this one. Then we have planes created to a curved surface. So how can I create this kind of a plane? I will come back to this one later. So I want to do a design on top of this curve shape. We can't do. So we have to create a plane. How can I do it? So here you cannot click on this and go to sketch mode. There is no sketch tools. If I click here, sketch tool is available, but not here. When you click, a sketch tool is not available. So we can't do sketches. So we have to create a plane and do the sketches. So we will do that now. So we come here and select this as the first reference. Automatically the tangent is started, and the second reference is the topmost point. So this is the midpoint, second reference, and now it's fully defined. So I selected the face here and the topmost point, and I created the tangent plane. So you can see the plane size can be increased. You can do a design here, no problem. This is a unlimited plane. The size of the plane is unlimited. Now if I want to do a sketch, we will do it maybe perpendicular. Now if I do a sketch here, I will just draw something like a circle. I can do it. Now if I want to start the sketch extrusion from here, we can do what? We can come here and extrude it. Now extrusion happens this way. Now if I press OK, what happens? There is a gap between this one and this. So you can see my circles are not displayed as circles here. It's like polygons. These are not smooth. So if you want, you can make this smooth in your computer. So it depends on the computer capability, processing power. You can have a perfect circularity here, or it's just like polygons in my design. But here all these are circles, but you can see these as polygons. That depends on your computer VGA outputs. So if you want to smooth your drawings, you can make it smooth by going to these additional settings. So there's a tool called options. We can just find, we can just type smooth here. We see whether I can find it. It's not coming. It's not coming. So I will go to here. Is that image quality? So here under image quality we can find it. So I will go back here again. Click on this. You can go to document properties, image quality, and you can increase the quality. So this will slow down your computer. So I will increase my quality now and press OK. Now you can see its circular properties are there. So if you come here and under document properties, reduce your image quality. So I will have something like this. Worst case, press OK. This is your output. These are circles, but you cannot see as. So we can improve our quality. So we will have something like this. So I hope you understood how you can change your performance of the computer. If the computer is slow, you don't have very hard, very smooth drawings. It will slow down your computer. Now I have extruded this side. There's a gap here. So if I want, I can extrude to the other side. So extrusion to direction to. If I give a blind value, it will go here. If I want, I can say reduce my blind value in the second direction. Now what happens here is when I look at the hidden lines, it's going inside. Since it's merging, if it is merging, there is no problem. Otherwise, if you want to do it perfectly, you can ask the software to use this up to next button. Software will automatically finish it nicely for you. Or else you use the up to surface and select this surface as your reference. That can be also done. This surface. It's not working perfectly, so we will use up to next. So now press OK. You can see nicely it's now finished. So this is how
So can you repeat that, please?
Okay. Or are you okay with drawing the plane?
Yeah.
Drawing the plane, then on top of the plane I do a sketch. I will edit this also. Click on this, go to sketch. Normally we don't draw sketches in this mode. We better you make it perpendicular to your screen, then you can easily see the 2D drawings. So I just select the midpoint here. You can just come and hover here and get the midpoint, or else you just draw the center lines and get the midpoint correctly. I just do a circle. Then I went to extrude. Now if I want to get the second direction on here, you just come here and turn the second direction. But it's going far beyond what I want. So if you just look at the wireframe, this is the outcome. Better you use this up to next. then automatically the software will find the next surface and finish it nicely. And if you want to have a hollow extrusion, you apply a thin feature. So the thin feature will make sure you are getting a hole inside the extrusion. It's like the thin revolve. Thin extrusion is also available. So you can change the direction, or else you can have mid plane, or else you can have two values for the thickness. Something like this. So I can get a hollow shape. I hope you understood. So okay, okay, this is the output. So it's nicely finishing. Just do it and see any questions, let me know. So we will look at the next method. Creating a plane in the middle of the two faces. So if you want to create a plane going exactly in the middle, how can I do it? So one way is we can select this edge, this surface, and give an angle, say 45. So rather than doing that, so I will do it and show you. So we can select this edge, and the second reference is this plane, and when we can come here and give an angle 40. So we are doing some additional work. So this can be done. Edge selected, face selected, and angle given 45. So that can be done. Or else you directly, without worrying anything, you just select this face and this face. Automatically he will do it for you. He will find the middle and he will create a mid plane exactly 45 degrees to this one. So I don't need to come and give 45 manually. Automatically these are big. Okay. So this is faster than the early method. I just selected this edge, give this face and angle 45 manually. Now what I gave is I gave this face another. So quickly this face given, it will drain through. So that is the last option available under plane creation. Just select this one, automatically it will do. And I skip this one. We have to do this one also. Uh, so others, any problems with the other plane creations? Okay, so I think that you don't have questions, so we will move on to the next one. So here we need to create a plane like this. Why we need planes like this? If I want to model a pipeline, sorry, if I want to model a pipeline, so pipelines are not straight. So you need to draw the sketches and sweep along this lines, along this curve. So there's a tool in SolidWorks called sweep, another basic operation like extrusion revolve. So we will see how the sweep tool works. So first we need to draw spline shape. So you can use arcs here, or else you can use splines here. So I will try to use a spline tool. Spline. Splines are several arcs connected to each other. So I just created a spline like this. Press OK or escape button. So this is my spline using this spline tool. Now you have to exit. When you create the spline sketch, exit. Now we need to create a plane to this point, perpendicular plane. So how can I create a normal plane or a perpendicular plane? Come here and create a plane to this point. So the first reference is this point, still it's underdefined. Second reference is this line. So I created a fully defined perpendicular plane to this point and the line. Okay, so now I created my plane. So you can do it and see. So just draw. This can be an arc also. So I use the spline. I exited from that one. Then I created a plane perpendicular to this point. Any questions? Let me know. Just try it and see.
So can you repeat that? Define the plane.
I hope everyone is okay with the spline. The spline can be an arc also. It's not a difficult thing. You can use an arc or a spline here and draw that and exit. I have exit here. Then you go to features, geometry plane. First point is this. First reference is this point. Second reference is this line. That's all, fully defined. SolidWorks is easy. Some software it's not going to be easy like this. Some software you have to give a lot of additional reference to get this kind of a plane. SolidWorks is somewhat easy. Now, why I created a plane here? I want to do a sketch. That's why I created the plane. So when you click on this plane, go to sketch mode, and I will now create a circle. Now snap is happening. A point is taken. Okay. All the relations are there. Now you have to exit. Now I have two sketches for the path and the profile. So this is a profile. So I created the path and the profile. So my idea is to create a pipeline. This is different from extrusion. So I have to use this tool called sweep. Swipe bus base. So I'm going to use this sweep tool, and I have a profile now. I have a profile. Profile is this. I will teach this one in depth later. Now for the time being, we will use this sketch profile method, and path is this. So you can see a swept bus base. So this is how we create a curve extrusion. This is like a curve extrusion. So it will follow the path. So it has two sketches, one for the profile, one for the path. So if I delete this sweep, I'm getting the path and the profile again. So I will repeat this. Sweep was base, sketch profile. So I'm using a profile. I'm using a sketch for the profile. If you go to this method, you are going to use a solid for the profile. So I will just use this one here, click here. And if you want to have a thin hollow shape, just give a thickness 1 millimeter. This side is not working. I think this profile is too little small. So this is how we create a hollow shape. Now it's called as sweep tip. Just do it and see that this is the usage of this plane creation. So we need to apply sweep tool. If you want to apply sweep tool, you have to have a perpendicular plane to the point here. It should be 100% perpendicular, otherwise it won't work. And I uploaded the last week videos to my channel. You can view it. I have given the links to Miss Katulika also. Uh, so these two videos I uploaded today morning, so you can look at them last week lectures. And if you go to playlist also, you can find them under SolidWorks. You have this one and this one. So if you want to look at the notes videos, just go through these things. Better you learn then and there rather than watching a video. Video will be around 1.5 hours. It's going to be bored. So better you learn then and there. Then it's easy. Uh, any questions about these plane creations? We will look at the axes and the other tools next day. It will be too much for you if I do everything today. Anyway, I have to slow down a little bit in this area. So we will look at a tutorial now. So we have discussed this direction tool in extrusion. Contour selections also we discuss how to get it from a single sketch. Cut extrusion I didn't do still. We will look at that later. So actually we have a lot to learn, but time is the problem. Your syllabus is very compressed syllabus. Simulation also I have to do. Now I'm going to do this tutorial. So now you can find tutorials are getting somewhat complex. So we have 3 views now. As I think you have done manual drawing, so you may have learned these things in manual classes. This is the front view, this is the right view, this is the plan view. So we have given 3 views because from a single view we cannot get that thickness of the drawing. So there are different thicknesses. So those thicknesses are given in these other drawings. So this part is 40, this part is 8, this part is 52. So from a single drawing like this, I cannot give that information. So that's why we are using other views also. So when it comes to this kind of a drawing, what can we do? We have extrusion method in our hand, revolve method in our hand, and sweep method also I just introduced. So what is the 3D method I am going to use for this model? That is the first thing you have to understand. So I cannot use revolve tool here. Obviously revolve tool is not going to work. Even in this one it's going to be difficult. Extrusion tool is the tool I am going to use. So for the extrusion tool to work, what is the 2D sketch I should draw? If I try to draw this one, it's going to be somewhat difficult. If I try to draw this one as the 2D sketch, it's going to be difficult. So if I draw this front view, it will be easy for me because I know the thicknesses. So you have to decide what to select when you get these kind of views, what to start, from what view I should start. So this is the view I should start, front view, which carries a lot of information. Normally if you take a human face, human body, front view is the front of the human body carries a lot of information. So we draw the face of the human, not the plan view of the human, which has less information. We don't draw side views of the humans. When we want a photograph, we take the front view of the human face, not the side views and other things, which is having less information. Same principle here. If you want to get lot of information, normally the front view carries lot of information. So I have to draw the front view. So I have taught you a method called contour selection. This method. So we have to obtain 3 different extrusions. So we can obtain it from a single sketch. No need to draw all the sketches separately. So we can draw everything in one sketch and do this design. So I will quickly show you how to do this. I hope you understood what I am trying to say. First, you need to understand what is the 3D model, 3D operation I should use. Here we need to use extrusion. Then we should decide what to start. What is the starting sketch? This is the starting sketch because this supports extrusion. So I will start from this. You can also start. So I'll take the front plane as the sketching plane, and I will draw center lines even though those are not mentioned. Better we draw these things. Then I'll take it here. Now origin, I can't figure it out the origin here. So origin can be here. Say I will take origin in the middle, or else origin can be here. So no problems. So we will start with easy things. Origin can be here. I will take origin here. So we will start. I will start from an easy. Take rectangle tools, and I'm starting. So we haven't used rectangle tools heavily, but here I can find that there's a rectangle. So we can use line tools and draw, or just directly use the rectangle. And this rectangle can be symmetric. Now it's almost done. If you want, you can make it 75 also, because this is a simple drawing. 75. It's easy for me to adjust now. 75. Then this is 90. Rectangle is done. Then uh, we can't draw these two lines because these two lines depends on uh, this groove. So better we model that. So if you want, you can model two circles and trim that, or else you model one circle, one arc and offset. There are a lot of ways. So I'll just use this one, center point arc method, and just draw something like this. Okay, it's a rough sketch. So I drew this one, 20. So I will the dimension here. Now from here to here it's 40. From the top here to the center point of this arc it's 40. So you can see all our rough sketches. This is drawn, and you can offset this by 8. 8. Side is wrong, reverse it. Okay, now you can complete. I didn't use mirror tools because it's a simple drawing. Now we can connect these. You can press the letter L and start the line tool. Then these two lines can be drawn, or else you can use, if you are smart, you can use this offset tools. Because this line is already there, I can use offset. Offset is value is 10, both sides is 10, right? So it should be 5 for one side, bidirectional this. So I use the bidirectional offset tool rather than drawing two lines. Okay, so it says 5. So that's how we have to think. Trim, just trim this. Okay, So almost done, but underdefined. So if you want, you can ask the software to fully define this. Still some black lines are there. We will ask the software to do that. So we have tools here, uh, fully defined sketch. We will select some entities and ask the software to calculate and try to make it fully defined. We will, okay, still underdefined. This blue line is there. Still underdefined. This point is, you cannot delete that. Now it's overdefined. Now it's fully defined. So you can make it fixed. So depends on your drawing. I can't say this is the only way of doing this. Now sketch is done. So you can try this one, then we will extrude. So let me know if you have any questions. I hope you are okay with this. If you are not getting fully defined sketches, just try it from the automatic tool. It will help you to get it. Then we will extrude this now. So when you come here, features, now we have to extrude different values. So base is 52. So we can select this base. Better you extrude both sides because it's a symmetrical drawing. So if you extrude this side 52, if you extrude this one 8 and 40, all are coming to certain in one direction. So there's a tool available called mid-plane extrusion here. So we can extrude both sides 52. So you can extrude both sides 52. That is the best way using mid-plane method. That pipe means that this groove shape. You can just look at the video recording if you have any questions. So I just drew a arc shape here and I offset that arc shape and click on the completed this line. So you just draw an arc shape and offset this arc shape and complete the other things. So I extruded this now. Now 52 is given. Then we have to have 40 and 8. You just come here and open the sketch and click here and go to features again. Extrude post base. Then this is 40. This side. And it should be mid plane 40. Sorry, this should be 8. Then again click on the sketch, go to the extrude post base, and this is now mid plane 40. Okay, that's all. So you can obtain the 3D shape nicely. So I did mid-plane extrusion. Otherwise, if you do in one direction, everything is going to this side. Nothing is this side. So that's why I use mid-plane extrusion. So extrusion also symmetric in this design. So you can try this and see whether you are getting it. This shape we can draw a center point arc using center point arc, and another arc can be offsetted. Then you can connect these lines, and I use the center line to get these offsetted lines here. Then I trim. That's all I do.
So how can I edit? How can I extrude different parts in a different times?
Uh, so you have the sketch like this. Then features, extrude. Use the select contour method. Click on this areas you want. Say I want to extrude this, but here it's extruding in one direction, so better you have it symmetrical in both sides. Then it's 52 here. Then open. Then the sketch disappears. You come here
Yes.
and open the sketch again. Then again go to extrude
Okay.
process. Then again select the contours. Mid plane. This is 8. Then again the sketch disappears. Click here again. Go to extrude boss base. Then again mid plane. This contour. This is 4. We are merging the results, so everything is merging, no problem. So this is how it works. So I hope you know how to read these 2D drawings. I heard that you did manual drawings in the you have done manual drawings earlier, so you may understand why how to read these manual drawings and get these shapes. So in the sides also I have mentioned how to do this sketch. So you have to do the front view and extrude in different sizes. Any questions about that tutorial? So if you have finished that tutorial, we can start this one, second one. Now gradually I am increasing the complexity. uh, Here we have cuts in my drawing. You have circular holes here. There's a small slot shape here, groove is there, small cut is there. So these holes are there. So where can I start from? What view I can start this draw? Again, the front view will carry a lot of information. If you start from this one, it's going to be difficult. I don't know these depths. So when this is the plan, it's difficult. Here, these can be used to get this extrusion thicknesses and the other information. So the front view carries a lot of information. I can draw the front view and start this. Now when you start the front view also, you don't need to draw these holes. These are separately drilled by the cut tools. So I don't need to draw this one, these two holes. And I don't need to draw this cut here also, that is later. We can handle that later. So these dotted lines are for this cut. So when you look at from the front view, you can't see this cut. That's why you have a small dotted line here. So I hope you understood what to start, what view I should choose. I should choose this view, but I don't need to draw these holes. So if you simplify the things, you have to draw only this shape. So if I take this to the other side, so you can see what to draw. It's not the cutting things we can do later, the cuts. So I don't need to draw the cuts here. I need to only draw the easy things which can extrude. So we can start with this sketch. So we have this is the actual shape, but we are starting with this. So I will start this drawing also. Uh, you can also start. So I have only removed these holes in this and this cut only. Other things are same. So you need to understand what to draw. Not everything given in the manufacturing drawing. So we don't need everything. So if someone wants to manufacture this, he will not cut this first. He will make the model and later he will drill these holes. And later he will cut this groove. So that's how the manufacturing happens. So you need to understand that also. So our origin is here. So you don't need to have the origin in the middle always. We can have the origin here. No problem with that. So I don't need to draw center lines in this drawing. This is not a symmetric drawing. So how can we start? We can see rectangles here. So I will start from a rectangle. That is easy. So front view selected. Then I will draw rectangle. So this time I will use corner rectangle. Origin is here. Something like this. Okay. So the rectangle can be adjusted 140. This is not the only way of approaching to this drawing. This may be the easiest. 140, 80. So I will apply that value. 114, 140. This value is 18. Okay. Then uh, these circles. These circles I can just draw somewhere here, so without any actual values. You just draw it. Later we can adjust. That's the whole idea of learning SolidWorks. Editing is capable, is supported. So now we can adjust, give these values 40, 20. Diameter 40 here, diameter 20. Then this is 50, 30. So circle diameters given. Now we have to locate the circles correctly. This is 56 from the bottom. So from the bottom here, 56. That circle vertical reference is given, not the horizontal reference. Horizontal reference we'll later give. We don't have a mention for that. 118 vertical reference for this circle. 118. From this corner it's 50. From the center, excuse me, from the center to this line it's 50. Almost done. Now this line is tangent to the circle, so we will draw a vertical line. You can just draw something like this. Vertical relation is applied. Now this circle should come and hit the vertical line. So how can we do that? We just select this as the parent, this as the child, and apply tangents. Automatically the circle will move this side and tangent relation applies. So I hope you understand. Now if you want, you can trim this. Using the trim to closet, you can trim. So other things are quite okay now. We have a fillet trim. So we don't need to draw this exact shape first. We can draw a L shape. If you try to apply a direct fillet, it won't going to work. So we will draw a vertical line, horizontal line from the bottom. Let's draw something like this. No worries. So you don't need to draw exactly the first thing. we can draw these things and trim. Now we have to apply radius 25 fillet. Radius 25. Select this vertex. Dimension. Okay, that's how it works. So I cannot get it from an arc also. To try to apply arc tool, this shape will not come because these are lines. Up to here, this is line, then fillet start, this is a line. So carefully look at the drawing. And this side is from here to here, this is tangent. So I will just apply a tangent relation. So tangent relation appears, you can see that. Okay. This is, so this is how we get the sketch. It's a fully defined sketch. We will save this. You can also try this and see any questions are there. So now we can, I will do this and get you at home. You complete this. I will quickly finish this. You can do it at home and finish. Now I have to give a thickness. Thickness is from here to here. If you look at my views here, it's 85. So the bottom shape is 85. So this time I don't need to have midpoint, mid-plane. It's only one direction extrusion, 85. Then this one is 12. This shape is, the thickness here is given as 12. So we have to look at all the drawings and you need to have a good eye to get these things. This is 12. Then I have two circles. One is 35. The top one is 35. So this one is 35. The next one is 30. So I got my basic shape. So the next thing is we have to drill. So I will discuss something about the cuts now. So we have to cut it. So this side we have to cut. So the cutting values are given here. It's 80 here. This rectangle size is 80. The height is 2. So what can we do? We have to select this side and go to sketches. Better you make it perpendicular like this. And we have to draw a cut of 80 and 2. So we will just draw a cut shape, something like this. It's not symmetric still. This length is 80. So it's going out of the model, no worries, later we can change it. This value is 2. Now we have to make it center to this thing. So we can do what? We can draw center line to this point, this sketch. So we have to find the center. We will look at that also. Just draw a line like this. Now this should be going in the center. So you can do what? You can click on this, and click on this and apply symmetry. So since these things are immovable, it's a stationary. This is also automatically moves. Now this is in the center. Now we can select this line, this center, and this line and make it symmetric. So I did it in a different manner. I drew a center line somewhere here and made that center line symmetric to these two edges, and then these two lines is symmetrical about the center. So I made the shape. Now I have to do a cut. So I am not adding material now. I will remove material. So remove material can be done blindly, or you can have up to next. Automatically he will find the next surface, and the cutting has been done. So you can see how the cut has been done. And here also we have 4 holes. So how can I do that? Select this, go to sketches. Better you make it perpendicular to screen like this. Then draw a circle. So this circle is diameter 10. From the corner it's 15, 20. So the diameter is 10. From the corner here it's 15, 20. 15, 20. So from the corner 15, 20, diameter 10. Now I have to have 4 holes. So what can we do now? Without straight away doing a cut here, then I am having only 1 hole. We can apply a pattern, what we discussed in the previous lessons, linear sketch pattern. So the pattern entity to pattern is this hole, and the gaps we can get it from this drawing 110, and between the circles it's not clearly given, so I will give 110 first. 110. Then we have to have an y-axis also. That value is not clearly given. This is 110. I think from here to here also 20. It's not clearly given. This value is not given clearly. 30. It's touching this one. Diameter is diameter of the hole is 10. So this is touching. Radius is 5. 25. So I think from here to the center is 25. The total value is 85. So 85 minus 25 is 60, minus 20 is 40. So from here to here it should be 40. So I am doing some calculations. So I hope you understood that 40. So how did I get 40 here is, I assume this is touching the circle circumference. So this is 30, this is 20. So total length is 85. 85 minus 20 is 65. From here to here 65. From here to here what is the value? 65. From here to here it's 25 because this is diameter 10. So 65 minus 25 is 40. So that's how I got the value 40. So I cut this way. Then we can go to extrude cut for all the holes, and it can be up to next. So this is how it finishes. Okay, so you can try this at home. Our time is over now. Just try this tutorial at home and ask any questions you have next day. So remember the thing, you don't need to draw everything which appears in the front view. You can draw the easy things, and later you can do the cuts. And next day we will look at this one also. This is also this is going to use these additional planes theory we discussed a few minutes ago. So next day we are going to do this tutorial, and next day I'm going to start chapter 7 also. So I have only 5 days to complete SolidWorks. It's very tough. task to complete SolidWorks in 5 days. Normally we do it for around 10 days, 13 days SolidWorks theory. So I'm going to look at chapter 7 next day. Some areas I'm skipping. Uh, so you will be able to do a basic model in your for your assignment. So next day I'm going to discuss whole tools, fillet 3D fillet tools, shell tools and other things next day. So please complete the tutorial and practice the software. If you can start this one, just have a look and start. It's given some ideas given in the slides. Just try it and see. So we will stop for today. We will meet next week.